Have you ever wondered what lies beneath the ocean's surface? Imagine a massive machine silently gliding through the deep, invisible to radar, carrying enough power to change the course of a war. This is the modern submarine, one of the most mysterious and formidable weapons in the world. But despite its advanced technology, why can't it stay submerged for more than 90 days? The answer might surprise you. Let's dive in. Why modern submarines don't stay submerged for more than 90 days. Modern submarines, especially nuclear-powered ones, have the capability to remain underwater for years without refueling. However, in practice, they rarely stay submerged for more than 90 days due to a combination of logistical, technical, and operational factors. One of the main limitations is food and essential supplies. While submarines can generate fresh water from seawater and recycle oxygen, food cannot be replenished while submerged. Storage space is limited, and after 3 months, food quality deteriorates, impacting both health and morale. Even with careful rationing, the strain of an extended deployment becomes noticeable. Beyond logistics, the psychological and physical well-being of the crew plays a crucial role. Life in a confined space without natural sunlight or fresh air can be mentally taxing, leading to stress, fatigue, and decreased efficiency. Although exercise routines and strict schedules help maintain discipline, performance naturally declines over time, making extended missions challenging. Technical maintenance is another key factor. Submarines rely on highly complex systems, including nuclear reactors, electronics, and air filtration, all of which require routine checks and repairs. Prolonged operation without maintenance increases the risk of system malfunctions, which could compromise both safety and mission effectiveness. Operational strategy also influences deployment duration. Submarine missions, whether patrols or combat assignments, are planned to maximize effectiveness without overstretching resources. The 90-day cycle ensures that the vessel remains combat-ready and that the crew can operate at peak efficiency. Once a mission is complete, the submarine must return to base for servicing, resupply, and crew rotation. Lastly, stealth and security considerations play a critical role. If a submarine remains submerged for too long, enemy forces may predict its movements and increase the risk of detection. Limiting underwater time helps maintain an element of surprise, ensuring the submarine remains an unpredictable and formidable asset. In the end, while nuclear submarines have the technology to stay at sea indefinitely, practical constraints such as food supply, crew endurance, maintenance needs, mission cycles, and security concerns make it impractical to remain submerged for more than 90 consecutive days. Torpedo launch mechanism in submarines. Submarines are equipped with a sophisticated torpedo launch system designed to ensure safety, maintain stealth, and preserve balance. This system relies on torpedo tubes, sealing hatches, and a post-launch stabilization process to prevent water from flooding the submarine. Each torpedo tube has 2 hatches, an inner door separating the torpedo room from the tube, and an outer door exposed to seawater. These doors never open simultaneously, ensuring pressure control and protecting internal systems. When preparing for launch, the inner door is sealed and seawater is pumped into the tube to equalize pressure with the ocean. Once balanced, the outer door opens and the torpedo is ejected using compressed air, a water-based launch system, or a swim-out mechanism for reduced noise. Immediately after launch, the outer door closes to prevent water from entering the submarine. Since the sudden loss of a torpedo's weight can disrupt the submarine's balance, seawater from the launch tube is redirected into ballast tanks to compensate. If needed, additional adjustments are made through the submarine's ballast system to maintain depth and stability. This carefully engineered process allows submarines to launch torpedoes efficiently while remaining undetected and maintaining operational effectiveness in combat situations. Maintenance and technical inspections in submarines. Submarines are marvels of engineering, operating in one of the most extreme and unforgiving environments on the planet. To ensure they remain fully functional and combat-ready, regular maintenance and technical inspections are critical. At the heart of a nuclear submarine lies its reactor, a powerhouse that allows it to operate for months without surfacing. However, to prevent overheating, radiation leaks, or system failures, it requires constant monitoring and precise adjustments. Beyond the reactor, advanced electronic systems such as sonar, radar, and navigation controls must be kept in peak condition, as even the smallest malfunction could compromise a mission. Life support systems, which generate oxygen and regulate air quality, are equally vital. Any failure in these could endanger the entire crew. The relentless exposure to high pressure and salt water causes gradual wear on crucial components like seals, valves, pipelines, and propellers, making frequent inspections and replacements necessary. If maintenance is neglected, a submarine could suffer power failures, navigation errors, or even hull breaches, turning a stealthy war machine into a vulnerable target. That's why, after every mission, submarines return to base for comprehensive servicing, where engineers meticulously check, repair, and upgrade systems, ensuring the vessel is prepared for its next underwater operation. Without this meticulous attention to detail, a submarine's greatest strength, its ability to operate undetected beneath the waves, could quickly become its greatest weakness. The 90-day deployment cycle in naval strategy. Submarines are among the most critical assets in modern naval warfare, tasked with missions ranging from reconnaissance and nuclear deterrence to offensive strikes and territorial patrols. To ensure maximum effectiveness, each deployment follows a carefully planned cycle, with 90 days being the optimal duration for a submerged operation. This timeframe balances multiple factors, starting with crew endurance. Operating in extreme conditions, confined spaces, high pressure, and total isolation from sunlight can take a toll on both physical and mental well-being. Beyond 90 days, fatigue and stress may reduce efficiency and reaction time in critical combat situations. Additionally, while nuclear submarines can operate for years without refueling, their mechanical and electronic systems, including engines, sonar arrays, and air filtration, have operational limits and require routine maintenance. Constant exposure to seawater pressure and currents also puts stress on essential components like propellers, torpedo tubes, and the hull, making periodic servicing necessary to maintain performance. Another key factor is crew rotation. Life aboard a submarine demands constant focus and intense workload management, and even experienced sailors experience physical and psychological strain over time. Rotating the crew ensures that those on board are always at peak performance, while allowing returning personnel to rest and undergo additional training. Furthermore, naval strategies evolve rapidly, requiring submarines to return to base for mission updates, intelligence briefings, and tactical adjustments. Staying submerged for too long increases the risk of adversaries detecting patterns in deployment cycles, potentially predicting when and where a submarine may surface. By limiting mission duration and rotating operations, submarines maintain their stealth and strategic unpredictability. The importance of stealth in submarine warfare. Modern submarines rely on stealth to maintain their tactical and strategic advantage, but staying submerged for too long increases the risk of detection. Advanced surveillance technologies, including sound surveillance systems (SOSUS), anti-submarine warfare (ASW) vessels with sonar, and patrol aircraft deploying scumways, can track submarines that remain in one area for extended periods. Even nuclear-powered submarines, capable of operating underwater for months, must occasionally surface or approach certain depths for communication, resupply, crew rotation, and maintenance. The longer a submarine stays submerged, the easier it becomes for adversaries to predict its movements and deploy countermeasures. Strategic unpredictability is a submarine's greatest strength, allowing it to remain an elusive threat. By limiting underwater duration and frequently shifting positions, submarines retain their stealth, ensuring they remain an unpredictable and formidable asset in naval warfare. Conclusion. In the end, while nuclear submarines possess the technology to remain submerged for years, the realities of human endurance, logistical constraints, and strategic necessities impose a practical limit. Beyond 90 days, food supplies dwindle, crew efficiency declines, and critical systems demand maintenance. More importantly, prolonged underwater operations could compromise mission effectiveness and secrecy. A submarine's greatest strength lies not just in its ability to stay hidden, but in its ability to strike at the right moment. That's why, after months beneath the waves, these silent hunters must return only to resurface stronger, resupplied, and ready for their next mission.